everyone. I'm Kunji Chen. I'm the corresponding guest editor of special issue of IEEE JETCAS in Q3 2020. The title of this special issue is Communication-Aware Design and Methodologies for Reliable and Adaptable On-Chip AI Subsystems and Accelerators. The guest editorial team includes Kunji Jimmy Chen from National Sun Yat-sen University in Taiwan, it's me, and the other three guest editors are Masumet Abramitz from KTH Royal Institute of Technology in Sweden, Maurizio Parsis from University of Catania in Italy, and Tim Goes from Synopsys in Germany. In these special issues, we accepted 10 outstanding papers, including 9 technical papers and 1 tutorial paper. The eventual acceptance rate is around 30%. The first question is, why do we organize these special issues? The primary reason is, although there are many special issues cover AI accelerator design, the issues of interconnection, communication, and computation together with memory subsystem, reliabilities, and flexibility of AI engines receive less attention. In addition, we found that the performance of current large-scale artificial neural network is often limited by the massive communication overheads and storage requirements. Hence, we believe that the flexible interconnections and the efficient data movement mechanisms for AI accelerators are worthy of study. We covered 3 interesting and timely topics in this special issue. The first topic is the new efficient data movements in contemporary AI subsystems. We investigate 4 papers to introduce the in-memory computing and near-memory computing techniques to accommodate the computing processing in memory issue. The second topic is used to investigate the new design methodologies for considering trade-offs among computing engines and data movement storage units. We solicited 3 papers to introduce the efficient test scheduling and data movement methodologies from energy, power, timing optimization point of view. At last, we accept 2 papers to introduce the research about the novel computing flow to address the problems of AI computing with flexibility and reliability for the third topic. Now, let's introduce each accepted papers in this special issue briefly. The first paper, according to the first topic, is communication-aware DNA accelerators on ImageNet using in-memory entry counting-based algorithm circuit architectures co-designed in 65nm CMOS. It presents a communication-aware processing in-memory deep neural network accelerator. The authors adopt the processing design, adopting a full-stacking co-design methodology from algorithm circuits to architectures to maintain a good classification accuracy of a CNN. The second paper is CASRAM, enabling in-memory computations for edge inference using charge accumulations on sharing in standard ATSRAM arrays. The author applies charge sharing methods to an in-memory computing primitives for accelerating dot products with standard ATSRAM caches. Because the proposed charge sharing approach can reduce the effect of non-idealities, the data errors in the memory can be reduced. The third paper covers in the first topic is attention-based activation planning to reduce data movements in real-time AI, a case study on local motion planning in autonomous vehicles. The authors present an attention-based feedback for the planning process to reduce activation maps in early layers of DNN. In this way, the data movement in real-time AI processing can be reduced. The last papers in the first topic is SRMPU, an energy-efficient CNN-based super-resolution processors with tile-based selective super-resolution in mobile devices. He introduced an energy-efficient convolutional neural network-based super-resolution processors for mobile applications. They also dynamically select the proper size CNN to reduce the computational workload of CNN-based super-resolution. Now, we move on to the second topic of this special issue. The first paper covered in the topics is MEMOPT, a scheduling and data reuse system to optimize on-chip memory using for CNN onboard FPGAs. It presents a novel scheduling algorithm and a data reuse system to optimize on-chip memory usage. In this way, the author can manage the memory efficiently on resource-limited FPGAs. The second paper in this topic is optimizing temporal convolutional network inference on FPGA-based accelerators. It presents a new accelerator architecture to optimize the execution scheduling of data transfer supports in the temporal convolutional network (TCN). Besides, the author implements the proposed approach on FPGA-based SOCs. The third paper in this topic is a latency-optimized reconfigurable NUCs for in-memory acceleration of DNNs. This paper points out the problem that crossbar-based in-memory computing may worsen the on-chip communication because of the weights and activations. With these motivations, the author proposed an autonomic NUC architecture along with a scheduling technique customized for different DNNs, aiming to reduce the communication latency. In the last topic of this special issue, we collect two papers. The first paper is Design of Sparsity-Aware Reconfigurable Deep Learning Accelerators Supporting Various Types of Operations. Because of the intrinsic sparsity features in modern DNN computing, the authors of this paper designed a sparsity-aware deep learning hardware accelerator to support efficient computations of various DNN operations. In this way, the authors can reduce the power consumption and increase hardware utilization simultaneously. The second paper is Hybrid Fixed-Point Binary Deep Neural Network, the design methodology for low-power object detection. The author combined fixed-point quantization and binarization techniques to compress the object detection model. In this way, this method can help to achieve lower bandwidth and low computational complexity. In addition to the previous 9 technical papers, JETCAS editorial team also have 1 tutorial papers to highlight the importance of the interconnection for the DNN accelerator design. The paper title is an overview of efficient interconnection network for deep neural network accelerators. In these papers, we investigate different interconnection according to diverse design goals and application deeply. After comprehensively investigating the state-of-the-art designs, we provide some promising research directions in the future DNN design paradigms. I hope you can like this interesting topic we choose in this special issue. If you are interested in it and want to know more detail, please scan the QR codes and find all articles from IEEE Explorer. Enjoy it, and thank you very much.